In this video, we're going to look at this compound interest formula. So where A is representing the future amount, P is the principal amount or the amount you start with, and we have R to represent the interest rate, N is number of times the interest is compounded in a year, and T is of course time. Now, for this particular video, we're going to focus on how to find the time required for an amount to reach certain amount if you start with certain amount. So that's the goal. Now you can solve for T algebraically, but first I'm going to show you how to find T based on an example, and then we'll solve T algebraically. Let's take a look at this problem right here. So we want to know what is the time required for $3,000 deposited at 6% compounded quarterly to reach at least $6,000. So you're starting with $3,000. So this is your starting amount. So let's call that one P. We're starting with $3,000 and we're getting an interest rate of 6%. So R is 6%, which is 0.06 in decimal. And we want to compound it 4 times a year. So quarterly means your N is equal to 4. So let's go ahead and write that down. N is 4. And we want the amount to reach at least this much. So that means 6,000 or more. So let's say we want to find the time when it's going to reach exactly 6,000. So the future amount is $6,000. And we're looking for the time that we require to attain this much amount. So let's go ahead and put this on the side and try to use the formula above. Future amount is equal to the principal times 1 plus R over N to the power NT. So instead of isolating for T, I'm going to go ahead and substitute in what we're given and just solve it algebraically. So we know A is equal to 6,000, P is 3,000, and we have parentheses 1 plus the rate, which is 0.06 over N, that's 4 to the power 4 times T. Now, algebraically, let's go ahead and divide both sides by 3,000 first. So I'm going to go ahead and divide both sides by 3,000 because I want to solve for T. So I want to isolate it as much as I can. And then this will give us, so 6,000 over 3,000, that's just 2, is equal to 1 plus the rate. So 0.06 divided by 4, that's about 0.015 to the power 4t. And now, if you see the variable you're solving for is an exponent, you have to use logarithms. So, because logarithm has the property allow us to bring the exponent forward and make it into a product. So you should recall from your algebra class that if you have a log of, let's say, a number to power c, then this is same thing as writing c times log of that number. So this is one of the property we're going to apply here. Only logarithms allows the exponents to come forward and turn it into a product. So that's what I'm going to do here. Since my exponent, the variable I'm solving for, is on the exponent right here, t, so I'm going to go ahead and apply common log on both sides. So let's go ahead and take logarithm on both sides. So just log like that. This is a log base 10. We want to use that for simplicity. But if you want to use any other base, but it is preferred to use base 10. So once I do that, on the left-hand side, I have log base 2. And on the right-hand side, I also have log of all of this expression. So I'm going to go ahead and add 1 plus 0.015. That's just 1.015 to the power 4t. And now, using the property on the side, this exponent come forward next to the logarithm. So this will be 4t times log of 1.015 equals log of 2 on the left side. So here we applied this property right here. So now I'm going to go ahead and isolate t. So t is right here. It's trapped between 4 and log of 1.015. That's just a number. So to isolate that, my last step would be to divide by that number, which is 4 log of 1.015 on both sides, of course. This is log of 1.015. And this would give us what t is. So on the right side, we have t is equal to log of 2 over 4 times log of 1.015. So that is the time. Now, if you put this in your calculator very carefully, you will see that you will get about 11.638. So you can round that up to 12 years. So we can say this, it will take about 12 years for the account to reach 6,000 if you started with 3,000 at this particular interest rate. So that'll be the answer to this problem. Now let's say you didn't want to go through it this way and you simply take the formula and solve for t algebraically, which will give you the exact same expression, but in more general form. So another way to think about it is to take this equation and now solve for the variable t. So we'll do the same thing. We'll divide both sides by the principal amount like we did above. So this will give you a over p is equal to 1 plus r over n to the power nt. And now you want to solve for t. T is an exponent. So we need to go ahead and take logarithm on both sides. So once you get to this step, we take log on both sides. Log of a over p is equal to log of 1 plus r over n to the power nt. And now the exponent can come forward. So once you apply logarithm by the property, you can bring this forward. This is equal to n times t times log of 1 plus r over n. And on the left-hand side, we just have log of a over p. And now how do we solve for t? Well, we know t is trapped between logarithm and that number n, so we divide. This will give us t isolated. So divided by n times log of 1 plus r over n on both sides. So this is n times log of 1 plus r over n. So what is time? So time is about log of a over p over n times log of 1 plus r over n. Now this is a very messy formula to look at, but we can do it. So I would strongly recommend you to just plugging it in like this. The algebra is exactly the same once you have your exponential term isolated. After you divide by p, just take logarithm on both sides. So that's what we did right here. And then keep on isolating, you're able to solve for t. Or you can do it by using the formula right here.